So you should be on number 1 in your package. And I'm gonna start by showing you the strategy to help you get this right, even if you look at something like adding rational expressions, like not something you're likely to get right, okay? And so here's how it works. And there's a little math behind it, but definitely not the math which involves finding common denominators and all that kind of stuff. The math behind it is this. If one of these 4 options here is equivalent to the given expression for all values of the variable, well, then it's got to be equivalent, it's got to be the same for one value of the variable. So let's just substitute a value for the variable and see what this expression equals, right, the given one. And then check the 4 possibilities, and whichever one has the same value, that's the answer, okay? Now, the calculator will do this for you. You just need to store a value for the variable in the calculator, okay? You probably don't know how to do this. Very few people at the school seem to, but this is how you do it. First of all, I could use any value of n, except, for example, if you look at the denominator of n plus 3, if I use -3, that's going to create a divide by 0. That's not good, or positive 4. Or if I use 0, that could like, make things turn to 0 that I don't want to. So it's important to pick the right value for n. And so the right value is pi. Let the variable equal pi. Okay, that won't cancel. They'll never use like x minus pi as a factor. So we want this n to equal pi. Now here's how you let the calculator know that n equals pi. Okay, first you put in the pi. Then you go to the button on the bottom left which says STO, that means store, and then you hit the capital N. So on the calculator, right, it looks like this. I'm going to clear my memory. Second plus 712. Enter. Right, so first go to pi. Now the pi is above the hat or the caret on the right side, right? So you go second, hat key, then you hit STO, and then you look for the n. It's above the key that's logarithm, right? So you go alpha log. On the screen it looks like pi, right arrow, n. Now you have to hit enter when you do that. So now the calculator thinks that n equals pi. Okay, now we're going to enter that expression in the calculator. Now, here's another thing that you can do with the calculators. At least at this point, I'm pretty hopeful you'll be able to do this on the test, but you definitely can do it today, is that you can enter this as a fraction. You can enter fractions as fractions, okay? And this is how you do it. You go alpha y equals 1. Right, so alpha y equals 1. So now I've got a fraction. Now let me put in 3n divided by n plus 3. 3 alpha n divided by alpha n plus 3. Right, now I go to the next and I say plus, bring up another fraction, alpha y equals 1, 5 divided by n minus 4, alpha n minus 4. Okay, now when I hit enter, it's going to evaluate that expression for n equals pi. And it looks like it's negative 4.29, etc., etc. So let me just write up here, negative 4.29 dot, 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 dot. Okay, now we want to, starting with letter A, put it in the calculator and see what it equals. Just type it in like that and hit enter and see what the decimal value is. Okay, until you find the right option there that has exactly that value, negative 4.29. Okay, while you do that, I'm going to solve it with math. Okay. So what, do you get it? Which one had the same decimal value? B. Right. Now, if you did it with the math, you got to find a common denominator. What's the common denominator between n plus 3 and n minus 4? N plus 3 times n minus 4. So then you had to multiply the first fraction by n minus 4 over n minus 4. That's here. The second fraction by n plus 3 over n plus 3. Then you simplify the numerator, and in the end it's 3n squared minus 7n plus 15, which is letter B. Right. So rational expressions, adding rational expressions, if you're not good at it, you've got a way to get around it. Okay. Second, number 3. Okay, factoring a difference of cubes. Another thing that we generally don't do very well. Okay, by far the most missed questions are usually rational and radicals, those kinds of things, right? Difference of cubes, also maybe a little bit of a problem. But again, let's store x equals pi, and then see what x to the third minus 216 is, and then compare it with the 3 options. Okay, so pi store x, enter. Second pi stow x, enter. And now I can do this, x to the third minus 216. And it looks like negative 184.99. Right? So go ahead and check the 4 while I do the math of it, right? Anybody? D, did you get that because of the decimal value? Okay, so the answer is D. But here's the thing, sometimes you can use a combination of a little bit of math and a little bit of, using the calculator. We know that a difference, sum or difference of cubes is a binomial times a trinomial. So really, there was no reason even to check A and B. It can't be anything less than a binomial times a trinomial. So really only check the last 2. If you're not quite clear of the formula, there is a formula. A to the third minus b to the third equals a minus b times a squared plus ab plus b squared. Right, this was x to the third minus 6 to the third. But you could either totally brute force it, just check all of them. Or you can make it a little smart, by eliminating 2. But still, do it by substituting a value. So we use the same method, right? The same method to solve both of those 2, which were totally different kinds of problems. And not kind of problems we usually get right. And if you do this, you got them both right. 2 out of 2. It's actually 1 in number 3. We skipped number 2. Okay, here's another totally different kind of problem, right? Subtracting radical expressions. But in the end, it's a multiple choice format. You can do it by storing a value, see what the decimal value is, and then check the 4 answers. Okay, try to do that. You already stored x equals pi. You don't need to do that again. Right? So just put this in the calculator, right? Put that in and see what the decimal is, and then see which one matches. And I'll do the math of it here. Okay? Did anybody get it? With the decimal trick? And you got D? And the answer is D. I mean, you have to split it up between what you can simplify and what you can't, right? Square root of 75. 75 is not a perfect square, but you break it up into 25 times 3, then you can do part of it. So both of those you could simplify and make them both like radicals, the square root of 3x, right? And then how do you add or subtract like radicals? By adding or subtracting their coefficients. 5x minus 3x is 2x. Again, that's the third completely different kind of problem that can be solved by storing a value. Okay, so it's only one method is replacing 3 kind of problems. Okay, so that answer was D. Okay, 5. Okay, same thing. This time it's simplifying a rational expression. If we were going to do it the math way, we would say factor the numerator. How does r squared minus r minus 6 factor? R minus 3 times r plus 2. Again, if you pause to factor that expression, then you should be storing a value for r and doing it that way, okay? This is intended to be a baby factoring problem in the numerator. I understand it's not for everybody, but that's why I'm giving you another way to get it right, okay? Don't be stubborn about it, just admit it. You're not good at factoring, okay? And don't worry about it. Here's another way to get it right. Right? R minus 2, R minus 3. And of course the R minus 3's cancel. So the answer is A. Okay, but again, this one you could have done that other way easily. Would have worked easily. We're going to get to that. In fact, we'll get to it right here. Okay, so now number 6, which is another different kind of problem, but it's in this multiple choice format, you will be able to store values. The thing is there's 2 variables this time, not just one. So when you don't want to use the same variable, because the same value, that could lead to some unwanted, combinations and cancellations. So usually if we have one variable, we would say let the first variable equal pi, and if there's 2 variables, we'll say let the second variable equal pi plus 1. And then we even have a pattern now, like what if there's 3 variables? Just do pi plus 2, right? It'll work, it'll because these are irrational numbers that are not going to be used anywhere else in these problems. Now, before I go down that path, understand that converting a radical to a rational exponent, right? We've done this before. Where in the rational exponent, meaning the fraction, does that index of the radical go? Right? If I have something like the b times x to the a as a rational exponent, that is x to the a over b, right? The index is the denominator when you turn it to a rational exponent. So we can see that the index here of this radical is 4. So look through your 4 options. You can eliminate a couple of them right away because they don't have an index, they don't have the denominator of 4. Which ones can you get rid of? You get rid of A and C. So at that point, you're welcome to, solve it with the math or store values. You would only have to check those 2 because it couldn't be one of the others. I mean, really, to me, if I had to split up this whole thing right there, I'd just say, what's the 4th root of 16? Just do the number part. What number to the 4th power is 16? 2. So there it is, right there. Right? It can't be 4. That's 16 divided by 4. That's not the 4th root. So, again, if you're playing along and you're actually doing this, that's out of the first 6 problems. That's 5 you should have gotten right, almost without fail. And they're some of the most missed questions on the test. Okay, here's 7. So we can add it 6 out of 7. This one doesn't even have a variable. Nothing to store. Just turn it into decimal and see what it equals. Right? I mean, if I don't, then I've got a FOIL. Right? 6 times 5 plus 6 times the square root of 7 plus 5 times the square root of 7 plus the square root of 7 times the square root of 7, which is 30 plus 11 times the square root of 7 plus 7. 37 plus. So 6 out of the first 7. How many do you need to get right? 27. 27. You got 6 of them in the back. Out of the first 7 questions, you got 6 of them. And I don't remember the number 2. We did that on the first go-around. I don't remember. That was operations with imaginary numbers, which you can do in the calculator. Right? We learned where the I was, so you'd actually be 7 out of 7 at this point. Okay, now here we go. Not a multiple choice problem. Which means for the most part, we're just going to have to simplify and do our best. But not quite. Not quite. Okay? Now first, when it comes to things like, how do I simplify the cubed root of 162? Is 162 a perfect cube?
No, it's not.
It's not? So here's a method you could do that. I have to say that I kind of made this one up this year with my Algebra 1 classes, and they did remarkably well with it. Because usually, I mean, if you struggle with those kind of things, imagine what they do. I mean, it's almost impossible. But this is what I showed them how to do, and it worked pretty well. Most were getting almost all of these right. Right? I went to y equals, and on the first line, I put x to the third. So I'm going to have a list of all the perfect cubes. X hat 3. And then on the next line, I put 162 divided by x to the third. Right. So when I go to the table of values, now the middle column are the perfect cubes. So I can go down that list, and you can see that 162 is not in that list, right? It jumps from 125 to 216. So I start dividing 162 by the perfect cubes less than it in the right column, in y2. And so look and see what you get. When you divide 162 by 125, you get a decimal. You divide by 64, you get a decimal. You divide by 27, you get 6. 6 times 27. That's how you're going to break it up. Right? So we're going to split this up like this. It'll be the cubed root of 27. I erase that. The cubed root of 27 times the cubed root of 6. Do we have to split up x to the 6th, or can we simplify all of that? How do you tell whether you can simplify all of it? But you divide 6 by 3. Divide the power by the index. And if it goes evenly, that means they're all coming out. How many of them are going to come out? 2. 6 divided by 3. But for this step, I won't simplify it yet. But we don't have to split it up. We'll just leave it like x to the 6th. And then we've got the third root of y to the 7th. Can I take out all the y's? No. So I need to split it up between the y's that'll simplify, the most y's that'll simplify, and then the rest, which will be y to the 6th. So the third root of y to the 6th times the third root of y. Right? Properties of exponent says that's y to the 7th. Okay, now I can simplify. The third root of 27 is 3. The third root of 6 can't be simplified. The third root of x to the 6th, x squared. The third root of y to the 6th, y squared. And the third root of y. Okay, so for the things that go outside, we need to pick 3x squared, y squared. And for the things that go inside, we have 6 and y. So beyond, I mean, you do have to solve it a little bit. I mean, could you have just guessed all of those? Maybe, doubt it. But one thing you could do is after you solved it, you could store values for x and y and just see, are these two the same? You know, they should have the same decimal value. If you put all the right things in the positions, they should have been the same. Okay. Okay, here's another one that you would be able to solve just by storing values. So we're up to number 9. We're at 8 out of 9. So the denominator of this is a 7. So what do I expect the index of the radical to be? 7. So which answers can I eliminate because it doesn't have an index of 7? A and B. So actually, that's your only decision right there. And you know, again, you could store values or you could solve. You know, we know that the third root of x to x to the 3/7 means the 7th root of x to the 3rd. And there's only one of them that's got that in it. So the answer is C. Now, why did the 36 over 7 is not something we usually deal with, but you know, that's y to the 35th over 7 plus y to the 1 or times y to the 1 over 7. You know, just add the exponents. And 35 over 7 is 5. That's where this y to the 5th comes from outside. Factor. You know, non-multiple choice. That'll be a challenge, no question. How do we factor when it's not a simple quadratic trinomial? Yeah, you'd have to say 8 times 5 is negative 5 is negative 40. What are the factors of negative 40 that add up to negative 18? Negative 20 and 2. Okay, what do you do with those? You split up the middle term. And then what? Group. And factor 4x times 2x minus 5y plus y times 2x minus 5y. So this is 4x plus y times 2x minus 5y. So that would be this one and this one. You know, I think that's a kind of a challenging problem, but that's why it's more important to get the ones right you can get right. You know, you got a way to get those others right, get them right by all means. I mean, again, you can also, once you've done this, you could check your answer by substituting values and just see, did I get these two to be the same? Okay, 11. Okay, what do you call it when you got fractions inside of fractions? It's complex fraction. Okay, but here's the thing. You can do this one too with storing values, right? Now that you know what the fraction format is, right? You can, in that fraction format, when you're in the numerator, just do the fraction format again. It'll put a fraction in the numerator and a fraction in the denominator, and you can type it in exactly like to see it. Okay. How did we learn that we're supposed to divide a fraction by a fraction? you flip and multiply. So this is n minus 15 divided by 9n times 3n to the 5th divided by 15 minus n. Okay, now you got to simplify. Right? Can you cancel the n minus 15 and the 15 minus n? Are they equal? No, they're not the same. But how are they related? They're opposites. They're opposites, right? 3 minus 1 is 2. 1 minus 3 is negative 2. If you switch the order of subtraction, you just get the opposite number. So what is n minus 15 divided by 15 minus n? It's negative 1. So yeah, you really can cancel them, but you have to leave a negative 1 behind. Okay. And then the rest of it, 3 goes into 9, 3 times. N in the denominator cancels with one of the n's in the numerator. It still leaves n to the 4th. So what's left? Negative n to the 4th over 3. But again, you can do this by storing a value for n. Put the original complex fraction in the calculator, see what it equals, and then run down your list until you find the same. Okay, that's kind of like the end of the expressions and operations strand, right, of questions. Now it's getting into the equations and inequalities strand. So how did we learn to solve a radical equation? You always start with the isolate, right? So in this case, that means subtract 4. So isolate. And then what? Yeah, I mean, I said undo, right? Because it depends on what the radical is. But in this case, it's a square root. So how do you undo a square root? You square both sides, right? So the square root of x minus 1 squared equals 4 squared. What is the square of the square root? They cancel each other. And now that is a pretty basic algebra at that point, right? 8x equals 17. X equals 17 over 8. Now, how else could you have done that? Which I know you're already a master of. What's that? Well, you could just like plug in those 4 answers until you found one that worked, right? Hey, now that you know how to like store a value, I mean, I would almost recommend like, start at 67/8. Say 67 divided by 8, store x, and then type the left-hand side in there and see if it equals 8. And then do the next one, do the next one. There's a lot less chance like for making arithmetic errors, order of operation errors. Because when you do the store thing, it takes care of all of that, I mean, have you ever tried to use the quadratic formula where it says b squared minus 4ac, and b is negative, and so you put that in and you get a negative, like it says negative 4 squared, and you get negative 16, because you didn't put the negative 4 in parentheses. But if you stored b equals 4, negative 4, and then let it do it, it doesn't make that mistake, ever, right? So it fixes all those little arithmetic errors. The other thing you could do is you could turn it into a system of equations, right? On y1, you could put the square root of 8x minus 1 plus 4. And on y2, you could put 8. And then how do you find the solution to a system of equations? Second trace 5, enter, enter, enter. And then it'll pick it up. Again, that's a method that will work for all different kinds of equations, right? So, you got logarithms and exponentials and radicals and rational, but it makes them all the same kind of problem. Put the left-hand side on line 1, put the right-hand side on line 2, do the second trace 5 process. In Algebra 1, you did graphing inequalities, right? In Algebra 2, evidently, we're doing graphing absolute value inequalities. It's the only kind I've ever seen on here. And it's not even quite clear in the SOL, in the standard itself, the way it's written, that this is going to be part of it. It seems like it's more those one variable when we solve greater thans and less thans in equations. But you do see that this comes in. Do you remember when you solved or graphed an inequality? Right? It was like a straight line. The line had to be solid or dashed, and then there had to be shading on one side of the line, right? So the same thing here. We would have to graph the V, figure out where the V goes, then figure out whether the V is solid or dashed, and then figure out where to shade. Okay. Well, if I was going to do this with math, which I don't think we did. If we did, we did very little in the first 2 weeks of the year. If you want to know where the vertex of the V is, the x-coordinate is the 0 of what's inside the absolute value. And what is the 0 of that? What value would you substitute for x so that 2x plus 1 equals 0? Negative 1/2, right? And the minus 3 is the y-coordinate. So we would be expecting that this thing has a v, the vertex is negative 1/2, negative 3. Okay, well, looking at your 4 options there's 2 of them that have that vertex. Which are they? A and B, right? These 2 not going to be our answers. Okay, now you got to figure out, should we be shading above or below the V? The V is the same V, but where's the shading go? Well, if it says y is greater than, then it means shade above. If it says y is less than, then you shade below. So which one do we want? A. Because you solve 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. But here's the thing. The calculator will actually do that for you. Right? This whole graph, you can have the calculator do it. And this may be a thing, honestly, there's going to be like one question like this on the test. One. So if you're overloaded with calculator things, then maybe this one you just say, I ain't going to do it. But this is how you can actually have the calculator draw an inequality or an absolute value inequality. Let me clear. Clear? Clear. Okay, so I need to enter that inequality on y1. Where do I find absolute value? No. What's that? Alpha window is probably the best place because, you can get it at math num, but if you go alpha window, you actually end up with 3 different functions that we kind of like to know where they're at. Absolute values, summation, and log base. Those are all kind of useful to us. But you can find all 3 of them somewhere else. But so I get the absolute value, and now I put in 2x plus 1. And now I go minus 3. And if I graph that, I'll see the V where it goes. But I want to see the shading too. So go back to y equals and scroll into the left margin. Right? It's like a thin line there because that's what the graph was. It was a thin line. When you hit enter, it changes the thin line to a fat line. We don't care about that. If you hit enter again, it changes the fat line to an upper right triangle. That's greater than. In the calculator, upper right triangle means greater than. So once you've got it blinking on that, hit graph, and then you'll see the V and you'll see the shading where it goes. So now could you pick it out? Right? So it's right there. Now, if we go back to that, just to show you, right, you have to hit enter one more time to get less than. It's a lower left triangle. So upper right means greater, lower left means less than. There's no distinction between or equal to or not. So you would never be able to tell the solid versus dashed line part of it. But you're going to get the shape and you're going to get the shading in exactly the right place if you could do that. Right? So I'll put in here. Right, upper right triangle, greater. lower left triangle, less I think when I asked that at the beginning, Gabe said second math, but he was confusing it. That's where you find the inequality symbols when you have a one variable inequality, right? Where we put that all to the right of the equal sign, but that's a different thing. 15. Okay, solve a radical equation. You know, honestly, I think most of you are probably going to get this right anyways, but you know, you could back substitute, you could turn it into a system. It's already isolated. So actually the next step would be cube it, undo it. If it's a cube root, cube it, right? I'm just going to do it right up there. That's a bad parentheses. Right, so that gives me 1/4 x plus 3 equals 2 to the third. 8. 1/4 x equals 5. X equals 20. Okay, and another radical. We've had square root, cube root, now we've got a fourth root equation. And they all work pretty much the same way. So, I mean, this is, and they're all multiple choice, which means you could just back substitute to find it. So you have plenty of options. Isolate. The fourth root of w minus 4 equals 3, right? So how do you make the fourth root in the calculator? Math 5, right? If you have to, they have a cube root function in the calculator. That's math 4. Anything above that, you go math 5. It gives x. It puts an x in that position, and then you got to scroll back over it and make it into a. So that's 3 to the 4th. So w minus 4 equals 3 to the 4th, which is 81. So w equals 85. Say again?
Like if you're doing the calculator, you set it equal to 0.
Yeah, you'd have to subtract 14.
So it'd be
the fourth root of w of x minus, or what are you going to do then? Graph it? Oh. I mean, I wouldn't subtract 14. I would just like put this in, put that in the calculator, and then see if it equals 14. If it doesn't equal 14, then go to the next one. Okay. Okay, now we got rational equations, right? And there's two kinds of rational equations that we solved. There's this kind, which is a fraction equals a fraction, and then there's this kind, which is not just one fraction on one side, right? If it's a fraction equals a fraction, then how do we start so that we get rid of the fractions? Cross multiply, right? So multiply 4n minus 37 divided by 3 equals 10. Oh, what did I do? I'm just copying that. Times n equals 3 times 10, which is 30. So 4n squared minus 37n minus 30 equals 0. So are there any common factors? No, 37's a prime numbers. You're not going to find any common factors. So you would have to go through that long factoring process or use quadratic formula, something like that, to find this. I mean, it's not that hard. 4 times negative 30 is negative 120. What are the factors of negative 120 that add up to negative 37? Yeah, so negative 40 times positive 3. So if you want to try to finish that off, at the same time, I'm going to make a system out of it. Clear. Oops. So on the first line, I'm going to put the left side, right? Alpha y equals 4x minus 37. Clear. Alpha y equals 1. 4x minus 37 divided by 3. Second line, 10 alpha y equals 1. 10 divided by x. Okay, and now I hit the graph. There's the left side, and there's the right side. Okay, I don't see any intersections for sure on that graph, so let me zoom out. Zoom 3. Okay, now I think I definitely see here in this zone, it looks like it intersects. So second trace 5, okay, it's on the line, that's good. Okay, look at the second curve, there's no y value. So that means you need to like cursor one way or the other to get the thing to jump onto one of those parts of the graph. And there, now it's on there. Guess, negative 0.75. Did anybody get that by the finishing out this? Did anybody finish the factoring? And nobody? Right. Group 4n times n minus 10 plus 3 times n minus 10 equals 0. 4n plus 3 equals times n minus 10 equals 0. So this one has got n equals negative 3/4. So that's that. Okay, or you can back substitute. Another multiple choice. Okay, this one you can't back substitute because there's no it's not multiple choice. So how did we solve these equations when it wasn't a fraction equals a fraction? You can't cross multiply. Well, you could set up a system. It actually works really well on this problem. If you're going to do it the way we learned in class, you would find the least common denominator and multiply both sides by it. You know, what is the least common denominator? X. There's only one denominator, and it's x. So if you multiply this whole thing by x, right, on the left you get 1 minus x plus 2x. On the right you get 7. So what does x equal? 6. Okay, now we're into a bunch of now that's the end of equations and inequalities. What? I mean, these are more knowledge questions than anything. I mean, either know it or you don't. What kind of function has a graph like that? Here's your options. Logarithm, exponential decay, exponential growth, inverse variation. It's inverse variation. How could you be sure? But just given these options, how could you tell for sure? Graph it. Just put it in the calculator and see. I mean, the inverse variation was the only graph we had that had two parts to it. So it'll be pretty clear. There's only one of them with two parts. So graph. Okay, which number is a zero of that function? You know, say again. I mean, again, graph it. What would you be looking for on the graph? The x-intercept. So just put it in the calculator. Look at the graph. I mean, this is probably the way you're going to do this. It's not like a trick. This is like how you do it. Oops. So graph. Y equals down, clear, up, clear. Log. There's the log for x minus 1. Now, if I hit graph, notice in my graph I'm still zoomed out. How do I make it go back to the normal view? No. Always go zoom 6. That'll get it right back to where it was. Okay, now even that, I can't quite see what's going on there. So now maybe I zoom in. Right, zoom 2. Enter. And what does it look like is the 0? I mean, yeah, I mean, between our choices here, you got 1/2 and 1/4. They're both between 0 and 1, but that's pretty clearly 1/2. It's not 1/4. So just look at the graph. Easy. Oh, did I do the wrong one? You're right. You're right. Sorry, it's been a long week. Don't worry, these last few go quick. Okay, ready? So what kind of function is that? 6 to the x minus 5 minus 4. It's exponential growth, right? So we're supposed to know what that looks like. You know, the basic function looks like this. It has an asymptote where? Right there. What is the equation of that asymptote? Y equals 0. That's the parent function, right? Y equals 6 to the x. Okay, but now the question is transformations. How do you shift the graph of the function when you subtract 5 inside the function? Up, down, left, or right? It's right 5. Okay, if you take that horizontal line, the x-axis, and move it left or right, does that move its position? You know, you slide it left or right, it's still there, right? But if you go minus 4 after the function, how is that moving the graph? Down 4. What is that going to do to the asymptote of y equals 0? Make it y equals negative 4, right? So that is down 4. You know, they could ask these questions about lots of kinds of functions, you know, if they really want to know about transformations. But it seems like they do it more with exponentials and logarithms than with anything. At least this one SOL, that is definitely what they did. Okay. So the whole graph goes down 4. So that's why it's y equals negative 4. And then this one, 32, which is like almost the same question. So it's almost unbelievable that they did that. So they've given you 4 different transformations of 2 to the x. Okay? This one is clearly a vertical transformation. So A and B, those are horizontal. Not going to be those. So your only question is this a graph that's been shifted down 3 or down 4? Okay, it's down 4. Don't look at the negative 3, right? The negative 3 is the intercept. it actually is down 4. It looks like this is approaching the line y equals -4, the same one we did on the last graph. Okay, okay, the graph of g of x equals log of 2x has, again, you're supposed to know something about logarithms, but even if you don't, graph it. Just graph it and look at it. How many x-intercepts and how many y-intercepts does it have? We're supposed to know that a logarithm function shaped like this, it has an asymptote on the y-axis, which is x equals 0. It never touches it, so it doesn't have a y-intercept. It has an x-intercept, but it doesn't have a y-intercept. So the only question is, does multiplying that by 2 inside, is that like a shift any which way? No, so it's not going to change that. You can verify that with a graph. Just look at the graph. But, you know, the one thing to be careful about with the graph is that, and the calculator, it's not going to look like that because it won't draw the line going all the way with the y-axis. It stops it. Just don't think that that means that it's actually touching that axis, because it doesn't touch that axis. Okay, increasing and decreasing. Okay, we just did that. It was in the homework. How did we tell where it's increasing and decreasing? You've got to look at the graph, right? You're not going to tell it just by looking at that there. Right? That's definitely not going to tell you. So graph it. Enter. Y equals clear. And that one was x minus 1 times x minus 4 squared. And then I go zoom 6 just to get me back in the middle. And they want to know what's the interval where it's decreasing. Okay. I mean, look at that. I mean, it's increasing until this point, and then it's decreasing, and then it's increasing again. So the question is, what is this interval right here? Where is it starting? All right, does this let me zoom in? No. And that's not 1, right? That's 2. It's starting to decrease at about 2. It looks like it lets me do that, doesn't it? And then go down to 4. And it definitely turns at 4 because it's a double 0. So the interval is 2 to 4. Right? One is the 0, but looking at the graph, it keeps going the same direction after the 0. It goes straight through. It's still increasing. Okay, and again, we know about logarithm. We just said a logarithm has an asymptote here. X equals 0. Okay, so the question is, which one of these shifts is moving the asymptote? Is it the minus 16 inside, or is it the plus 15 outside? The minus 16. Which way did it move the asymptote? To the right. So what's the new asymptote? It used to be x equals 0. Now what is it? X equals 16, right? So this way, 16. Right, that's right 16. Bingo. Last question. What is the range of that graph? Remember, what does range mean? Y values, right? So which Y values does that graph have? 1, 2, 3, and 4. Right? It's just 4 little segments. In fact, we're supposed to know a little something about this function. It's called a step function. And you could actually do it in your calculator, but it doesn't come up much. Like in this scenario, that's about it. So the range is y equals, that's actually set notation. The set of all y such that y equals 1, 2, 3, and 4. Okay. Not that you cared. So that is the homework. Sorry that it was so long.